Hi everyone. The previous so far we looked at the polynomials and how to add them, multiply them, subtract them, the idea of like terms and how like terms combine and unlike terms don't combine. And as pointed out, the next goal is to go from addition. So here's the goal. The goal is to go from, let's say, I have in addition a bunch of things, and from here I want to get to the product of a bunch of things, maybe one thing or two things. So the motivation for this comes from numbers. Right? Numbers can be factored down into prime numbers, meaning any number can be written as product of small numbers which are prime. For example, 12 can be written as 2 times 2 times 3, 8 can be written as 2 times 2 times 2, 14 as 2 times 7, 18 as 2 times 3 times 3, 22 as 2 times 11, 27 as 3 times 3 times 3. Or another way to write these things is 2 squared times 3, 2 cubed, 2 times 3 squared, and 3 cubed. Okay. Now, how this helps us is when we have to find something called the greatest common factor between two numbers, we can use this factoring technique. Let's see how. For example, from our list above, 12 is 2 squared times 3 and 8 is 2 cubed. So what is the greatest common factor? Now, common factor meaning something that appears in both. Now, 3 definitely does not appear in the second one. 2 does, but how many of them? There's exactly 2 of these, so 2 squared, okay, which is 4. And what's special about this number? 4 is the largest number that divides both 12 and 8. Let's look at this. 2 squared times 3 and 2 times 3 squared. Now here there's both 2 and 3 involved. So 2, and we take the lowest power of 2, which is 1, and the lowest power of 3, which is 1. So this is 6. This is 2 times 3 squared and 2 times 11. Well, there's no 11 in the first one and there's no 3 in the second one, so they're not going to appear. The only thing common to them is 2. 2 times 11, 3 times, or 3 cubed. Now here there's nothing common. So if there's no other factor common, then we say the greatest common factor is 1. Because then the largest number that divides both of them is 1. Now our goal is to apply the same idea to polynomials. So for example, let's say this is a polynomial. What are the factors here? Okay, so you can compare it to the number situation, right? So like for example, 12 can be written as 2 squared times 3. Then the factors are 2, 2 squared, and 3. So over here, for example, then the factors are x minus 1, x minus 1 squared, x minus 2, and x minus 3. Or let's to make it more, and then factors for this one are x minus 5, x minus 6, x minus 2, x minus 2 squared. So what's the greatest common factor? So we use the same rule, right? There is x minus 1, there's no x minus 1s here. X minus 2, there is, the lowest power is 1, so it's x minus 2. There's no x minus 3 in the second one, and there's no x minus 5 and x minus 6 on the first one. So the greatest common factor here is x minus 2. And you can see that's the only factor that is dividing both of the polynomials. So GCF for polynomials, same as number. Yeah. Factor polynomials. Factor the polynomial and then collect the lowest common factor in both, right? So for example here, x minus 1, we don't collect that because there is no x minus 1 on the second one. X minus 2, you have a power 2 and a power 1, so we collect the lowest one, which is power 1. X minus 3 doesn't exist on the other one. Similarly, x minus 5 doesn't exist on the first, and x minus 6 doesn't exist on the first one. Okay, so this gives rise to some factoring techniques. We're going to do 3 different levels of these. So it's called factoring with a greatest common factor. So level 1. Here we observe that we are adding two things, x plus 1 squared and x plus 1 times x minus 2. And the first observation is that the GCF of the first and second term is x minus 1, right? Which means I can factor out an x minus 1 and I can rewrite this as x minus 1 plus x minus 2. Now let's look at what I did here. So this is the opposite of foiling. Why? Because if you FOIL this, x minus 1 times x minus 1 gives you x minus 1 squared. And x minus 1 times x minus 2 gives you this. Right? So they are the same thing, meaning this operation is the opposite of FOILing. So, which further simplifies. So over here we can combine like terms. X plus x is 2x and negative 1 minus 2 is negative 3. So this would be called the factored form. Now it is inherently, it's the same thing as what we started. These are all equal, but it looks nicer because instead of having addition of a bunch of things, now I have product of two things. Now the same thing here. The factors of these are x squared y, and x, y, y squared. So there's an x in both, but the common is just 1. The lowest power is 1, and the lowest power of y is 1. So if I factor out an xy, I'm left with x plus y, and that's it. That is the factored form. Okay, this method is called factoring with the GCF. Now let's go to level 2. There are 4 terms here. Okay, so I look at the first two, and what's common in them is x, right? So I go 1 plus y. The next two terms, what is common is z squared, and then it goes 1 plus y. But now there's still an addition in between. However, we notice that this 1 plus y appears in both, right? Which means I can factor out this 1 plus y one more time to end up with x plus z squared. And this is now my factored form, because it consists now of product of two expressions. Let's do the same thing here. I look at the first two, and I can factor out a 3x to give me 2x plus 1. And the next two, and I factor out a y to get a 2x plus 1. Now when I'm here, I can again factor out all of this, 2x plus 1, to be left with 3x plus y, which is again the factored form. So level 2 would be you have to do the factoring by GCF twice. And then lastly, level 3, actually this is still sort of level 2 because you factor out x squared and you get x plus 1. Oh, I see why I put this in level 3. X plus 1 doesn't have anything in common, but that means their GCF is 1. So you can always factor out a 1. And the reason I do that is because I can already see that in the future step, in the second step, I'm going to factor out x plus 1. So I'll be left with x squared plus 1. Yeah, so if they don't have a greatest common factor, you can always factor out a 1 and that still works. And in this last example, before we do the GCF, or there's again 2 levels of GCF factoring here that might happen. What we observe is that there's an x in all 3. So the lowest power, so the GCF here is x squared. So I factor out an x squared, I have x to the 5 plus x squared y cubed plus 1. Okay, so you may have situations where maybe there's not much you can do. There's not much factoring you can do. All you can do is pull out an x squared. And then that's it. That's the factored form. Okay, so these are examples of factoring with GCF. Now, in the future, we're going to learn more factoring techniques which are applicable for very, very specific cases. And we are going to learn a couple, 2 to 3 different ways of doing it. Actually, by the end of this course, it'll be like 4 different ways in which you learn this. Okay, that's it for this video.